So as Jordan said, I'm Alan Brent. I head up the Sustainable Energy Systems group in the Wellington Faculty of Engineering. Bit of background to this webinar. So Engineering New Zealand has an engineering heritage board that focuses on telling the stories of our past engineering achievements. They also have a heritage specialist or special interest group, which is basically a cross-disciplinary group of not only engineers, but professionals in adjacent sectors that work with heritage structures, sites, and values. Engineering New Zealand also maintains a register, which is basically a list of the most significant engineering heritage places across the country. And last month, they added Manapōuri Power Station to the register. Now, as most of us will know, that Manapouri was commissioned back in 1971, which is my birth year, so it's one of our oldest power stations, as also the largest hydropower scheme in our system, and is really important for a vital part of our electricity infrastructure. And yeah, so it has apart from the achievements, it has a very rich social history, sort of a story that goes beyond just engineering. It's all about politics and industry as well. Incredible engineering, of course, and growing environmental awareness. So there's quite a rich history associated with this project. And today, to speak to us, we have three excellent panelists. Keith Turner, who's the board chair of Transpower, and he has a long association with Manapouri right back to 1967 when it was under construction. He'll be followed by Brent, who's the head of electricity supply and previously a site manager at Manapouri. He's with Meridian Energy. And last but not least, Caroline Rios, who's the civil engineering manager of renewable construction at Meridian Energy. So, as Jordan said, the way we're going to run this is I'm going to give each of the panelists 5 to 10 minutes just to introduce themselves and give a bit of their perspective on the power station. And after the three talks, we have some questions that we already have from our end. But as Jordan said, please pop any questions in the Q&A, and we're going to handle that after the three speakers have spoken. But then we'll definitely aiming for a hard finish by 1:30, so we can all get back to our job. So with that, Keith, I'm going to hand over to you.
Thanks, Alan. Yeah, I've had a long association with Manapouri going right back to when I was 17. And I took off from Rotorua to do a South Island trip in a 1948 Series E Morris 8, and luckily managed to cross the lake at Manapouri and visit the project under construction. So one of the photos in the slide pack is a picture I took of the main intake structure being excavated. That followed up with doing a practical period for my university degree at Canterbury in 1971-72. It was just after the final 3 machines were commissioned. The station was commissioned in 2 stages. Bechtel did the first 4. The second 3 were commissioned by Wilkinson Davies, or installed and commissioned by Wilkinson Davies. And that was the time when the tunnel performance was discovered to be underperforming. We couldn't run the station at its expected full load of 720 megawatts because the tailwater level rose too high for the anticipated back surge that might arise from a total station disconnect. So I was lucky to be there when Professor John Undrell was sent down to the station to revise all of the governor settings and establish the maximum rating for the station, which ultimately turned out to be 580 megawatts. So I worked with John Undrell to do those governor setting changes and got deeply involved in a lot of the calculations around the station performance. And obviously at a tailwater level above 100 feet, the back surge was enough to flood the station. So this work was pretty important. And it was interesting, but Bechtel had escaped any liability for the underperformance of that construction because the second machines were commissioned later than the first. And it wasn't until we had 7 machines that we could put enough water into that tunnel to discover its shortcoming. It was quite important because the station was originally built to feed the smelter. It was intended to be a Comelco station, but ultimately got built by the state. But the state took on a contract to feed the smelter with its power. So there was a pretty critical issue behind that shortfall that actually cost NZED a considerable amount of money. After that period over the summer of 71, 72, I went back to university, did a master's, and then came to work in Dunedin. And there was a lot of conjecture about why the tunnel wasn't able to perform. Its hydraulic resistance was much greater than anticipated. So I was given the task of working out why. And one of the jobs I undertook was to throw a cylinder that had a strain gauge on the end, and which was feeding directly to a tape recorder inside, in order to measure the pressure up to 10 kilometres. Theory being that if we'd had a cave in the tunnel, the water would have to be travelling fast through the area of the cave-in, and Bernoulli's theory said the pressure would drop. So I was anticipating that we would discover a short pressure trans tunnel. We just with no tape recorder in it, we found the best need to recover the other end. So that disappeared. It belonged to the district manager of Dunedin. It was a great status symbol. I was obviously kicked off for order into the we ended up doing a lot of ultimately the surface roughness of the tunnel, where it had been slip formed brings the cement to the surface had corroded away because of the acidity of the water in Lake Manapouri, and that roughness over 10 kilometres was just enough to increase the drag and raise the tailwater level under full load. So back in 1994, I took over GM generation at EC&Z. We continued to think about how to solve that problem. Lots of ideas. One idea was actually a hollow tunnel boring machine that would ream the existing tunnel out and use the water flow while the station continued to operate to carry all the tailings back out into the into Deep Cove. Of course, it was never practical that we could do that, but it just shows you some of the innovation that was dreamed up. We ultimately concluded a second tunnel with a tunnel boring machine rather than drill and blast. And I was appointed Tom Martin as project director for that project in 1996, just prior to, or no, 1995, just prior to departing from EC&Z to set up Contact Energy. Of course, I ended up taking over the tunnel project in its early phases of construction in 1999 when Meridian was formed, and I was the inaugural chief executive of Meridian. At that point, the tunnel contractor, which was a consortium of Fletcher's, Dillingham, an American firm, and Ilbau from Austria, were having real trouble with their progress. They had bid the contract on an average distance of 20.5 metres a day. Their TBM performance was only 8.5 metres a day over the first quarter of the tunnel. And I could see that we were going to face a very large contractor claim if we didn't do something to overcome this slow progress. One of the things I did as Meridian CE, I I offered $1 million to all of the staff that went up the tunnel to work. So anyone on gumboots was eligible for the $1 million. It was not eligible for those who worked in the office, either at Deep Cove or at Manapouri, because I really wanted the guys who were doing the hard work, the hard grind in the tunnel itself, to be strongly incentivised. That $1 million was payable if the team could deliver 15 metres a day for a month, which they subsequently managed to do. And it was a real message to the project management, and ultimately became a very critical factor in the large dispute that was raised by the contractor after the first quarter of the tunnel was finished. We had an international review board. That review board listened to the evidence. I then sat down with Mark Binns, who was Chief Executive of Fletcher Construction, outlined to him where he stood, outlined to him where I thought we stood. He did the same. We shook hands and we solved that dispute. And I think in the end, it cost Meridian about $240 million against a contract sum of about $220. But I do know that the Fletcher-Dillingham-Ilbau consortium suffered a significant high cost from that project. We commissioned it in 2003, I think was the date. The picture in the pack of the TBM breaking through was a fantastic moment. I managed to be there. I was standing right beside the photographer when that photo was taken. And it was great jubilation to the team to bring the project home. And of course, that project, at its early days, because of the slow progress, we were thinking of abandoning it. When we finished, that project was of enormous value to the power station and lifted its rating to above 800 megawatts. I'll let you into a wee secret and then I'll finish. Subsequent to the drilling of that second tunnel, we systematically went through and refurbished the generators and the turbines. The turbines were replaced by Hitachi back-angled intake runners. A fantastic runner, very, very much quieter than the old Canadian runners that were there, but capable of 145 megawatts. So I said to my team before I finished at Meridian, that station must be capable of 1,000 megawatts. So I believe we actually got it up over 1,000 megawatts on a day when we had a very low spring tide, a very high lake, and we obtained a special discharge consent from Southland District Council for a period of 1 day. And I do believe that station got up over 1,000 megawatts for a brief period of 10 minutes. Obviously a significant security risk in the South Island to stay there for too long. So look, it has been an enormous workhorse for the country. It's been a critical element to the supply to the smelter, and it is a very innovative design in its day. To finish on real history, that project was originally conceived by a bunch of public works surveyors who were sent around the country in the late 1800s. So 1896, 97, 98 was one survey program, a second survey program in 1903-45. That scheme was observed and identified by those surveyors way back that far. So it took 70 years to bring that dream alive, but it has been a fantastic workhorse. Enough from me.
Great, thank you very much, Keith. That's very interesting and rich history, as we said. I'm sure there's going to be questions coming to clarify some of those issues, perhaps. So, I'm going to hand over to Brent.
Thanks, Alan, and thank you, Keith. I guess disclaimer to start with, my history associated with the site's a lot shorter than Keith's. And I thought I might just start with a little bit of how I got my connection and into the world of engineering. I started life in the energy sector. My father was working in the Wairiki scheme up in the North Island. We spent some of my early years living over in Kenya, where he was helping build another geothermal power scheme in Naivasha. And I guess it was through those early days of trudging around on the back of rig sites and around big bits of machinery that my love for engineering really sort of cemented itself in my brain. I sort of first started working myself in the energy sector in the UK, in the North Sea. I worked on a number of different assets in the North Sea, helping the industry manage the produced water challenge that they've got. There's quite large environmental challenges associated with the sector up there. And after 5 or so years, decided to move back to New Zealand via a overland trip through Africa, which really sharpened my focus on the amazing abundance of natural resource that we have in this country, but also an appreciation of just how quickly that can be lost. And came back to New Zealand looking for something that was going to maintain some involvement in the energy sector, but have a big focus on protecting our access to natural resources, and particularly the freshwater supply we've got in this country. And so I started work at Meridian as a project manager in 2012, and all the work I've done since has had a direct link with the Manapouri site. As a I guess few projects that I was involved with initially, there was a $10 million replacement refurbishment of the ventilation system that provides above ground service here to the powerhouse. That was a big focus after the Pike River event on the west coast, and certainly gave us some pause for thought to how we operate that site down in deepest, darkest Fiordland. Was also involved in a replacement of the transformers. So the original Civigliano transformers that were rewound as part of that half-life refurbishment that Keith was talking about presented some problems with a fin failure in the oil water coolers, and prompted an unplanned replacement back in 2015. And it was then that I guess really came to grips with the challenges of operating within a national park World Heritage site in West Arm, which is, for those that don't realise, doesn't have a national road connection. And even after taking many tenders through that site, it's still a conversation that we regularly have to have when they look on Google Earth and think that they can take equipment across the Percy Pass line. Anyway, partway through that project, I'd been completing an MBA and developed quite an interest in the world of leadership, and the site manager role came up. So I put my name in the hat, and moved the family down to Te Anau in 2017. Still based there now, so I'm talking to you all from Te Anau today. And through that time, have seen, I guess, the tail end of automating the site. So the site itself went through a major automation upgrade in 2000. In 2018, I think, we completely demanned the site, which was a pretty big and scary move. We went away from having on-site operators on site 24/7 to operators just working a normal week working pattern. So that was a big change in my world, and I guess the impact of it really reinforced by also being part of the 50th celebrations for that site. I was really fortunate to meet a number of people that were involved in construction and operation of that site. It's a site that continuously surprises me about the number of New Zealanders or their families that have had a direct association with it. And it was also quite a telling reminder of the impact that fatality in the workplace has on families, even 50 years after the event. There were some pretty emotional moments in that celebration, just hearing the stories of some of those workers that have been involved in some pretty nasty accidents during the original construction of that site. I guess towards 5 or so years into the site manager role, I started to see some of the hydro is a technology that's been around for many years, and one thing that I found a little challenging towards my later years in the site manager role was just the barriers to change that sometimes exist in those type of industries where there are some very well established practices. And I guess some of what we'll end up talking about today, and it's probably a good segue into some of Caroline's discussion, will be the challenges that we're facing as a sector at the moment around managing the uptick in demand across our country, and the ways that we're navigating that through investment in alternative generation supplies, but the really helpful tension that it's created in the hydro space is just forcing us to think about how we operate our plant, how we operate and maintain it, and shift from a mindset of a sort of a base-loaded generation asset that supports security of supply for New Zealand to something that we can also flex and navigate our way through the morning and evening peaks that are becoming more and more stretched in our sector. So yeah, that's been a really interesting challenge and something that I'm quite focused on now. My current role is head of electricity supply, as Alan said, so it's looking after all of Meridian's generation sites across the Waitaki and Manapouri schemes, as well as our wind assets in the South and North Island. So yeah, it's a pretty interesting space to work in. There's lots going on at the moment, and yeah, to have it all founded on some exposure in the Manapouri site's been a really good foundation for me to jump into the electricity sector in New Zealand. That's probably enough for me, I think, Alan. Just mindful of time. I'll let you move the talking stick on.
Thanks, Brent. I don't see any Q&As coming through here, or Qs rather. Please do so, and then I'll hand over to Caroline.
Thanks, Alan. Kia ora, everyone. My name's Caroline Ray, and I'm the Civil Engineering Manager for Meridian's Renewable Construction team. So I'm going to be talking a little about what Meridian's doing to help decarbonise the country and some of our new developments that we're doing. So first of all, a bit about me and my career progression. I grew up in this holidaying around the South Island hydro dams and lakes, and was always in awe of these amazing structures. When the opportunity came to studying engineering, I thought what a cool, how cool it would be to be involved in constructing one of these engineering marvels. However, when I graduated from university, it was just as ECNZ was being broken up and there weren't really graduate opportunities in any of the new power companies. So I ended up pivoting and doing roading and traffic safety engineering for 10 years instead. I then pivoted again back when I got an opportunity to join Meridian Energy as a project manager in 2011. I worked for the strategic engineering team, which basically was the team that was to deliver major refurbishments and upgrades to our power stations, dams and gate structures. So my first project lasted 5 years and was looking after this beauty. This is Meridian's oldest station, which is Waitaki. Waitaki was built over 2 stages, first as a Depression era project in 1930, then it was expanded in the 1950s. The 7 original 15 megawatt generating units are still operating, and the powerhouse and dam are basically in original condition. However, as part of the project that I was involved in, I managed the seismic upgrade to the powerhouse. I mitigated erosion of the sluice pier and tail race below the substation, improved fire protection around the transformers, enhanced uplift drainage under the dam, strengthened the retaining wall on the true left of the dam, and permanently removed the auxiliary generators. One of my other little projects I had to do was upgrade our beautiful wood-lined lift in the station. I then moved on to managing the refurbishment of hydro generating units at Ōhā Power Station, which kept me busy for another 3 years. In 2022, Meridian set an ambitious target of 7 and 7. This was one new generation project approved for construction every year for 7 years. In order to achieve this, Meridian decided to re-establish a renewable construction team. I took the opportunity and joined the team as the civil engineering manager. So our team now basically takes projects that have been secured and consented by our development team and take them through detailed design and construction. So Meridian currently has 2 sites under construction: the 176 megawatt Harapaki wind farm in the Hawke's Bay. 3 of the 6 strings of turbines have been commissioned, and the remaining 3 strings are being progressively commissioned over the coming months. I just had to include that one. It was quite a pretty photo, I thought. We are also building the first grid-scale battery storage system, or BESS, in Ruakaka, south of Whangarei. It's just down the road from the old Marsden Point refinery. This will be a 200 megawatt hour battery, which consists of 80 batteries, which are housed in 20-foot shipping containers, and 20 power conversion systems. I was the design manager and civil engineering manager during this design phase of the project, and have found that designing this new technology and product with no established guidelines or standards has actually been really challenging. While the electrical design is similar to other sites, the civil design, OEM interfaces and operational requirements are different to what we've encountered before. Now, the project is well under construction, as you can see in this photo, and the first of our shipping containers have arrived in the country. We're also working on our first solar farm, which is adjacent to the BESS site, and this is going through resource consent. But my other major project that I'm working on at the moment is the Te Rere wind farm. So Meridian are partnering with New Zealand Wind Farms, who own the existing Te Rere site, to extend and repower the site. So there are currently 91 two-bladed wind turbines on the site, and we're looking at replacing them with 39 bigger turbines over a larger area. The output of the new site will be 6 to 7 times the output of the original wind farm. I'm leading the civil design for this project, and while you may think redeveloping a wind farm would be straightforward, the size, weight, transport and craneage requirements of the latest turbines are very strict and require major redesign of all the existing infrastructure. So that's just a wee bit about me and what Meridian's up to at the moment.
Great, thank you very much, Caroline. I think there was a question here from Mark, and maybe that's a good place to start, because he wanted just to go a little bit slower through those photos and slides. Keith, maybe if Jordan, if you can put those slides, just to give a bit of a description of each of those photos and so on, would be awesome.
You're gonna go through the slides?
I'm going to ask Jordan to just put it up there. Yeah.
So that's a view of the station from West Arm of Manapouri, and you're looking back down West Arm from looks like a hill, or from the hostel, and to the left-hand side, 4 towers, which are the 4 transmission circuits down to Tiwai, and a substation which is just behind those towers, open air, and the cables from the generators come up into that substation for the normal bus work. The control block is just to the right-hand side of the rightermost tower, and the control gates are below lake level at the screens down at lake level, and there's a boom around to prevent logs from getting in there. So that's what you can see from above. Next slide. Schematic of the station, about a 700-foot drop from the lake down to the powerhouse. Powerhouse is a big cavern accessed by a spiral roadway, and you can see the surge chamber. There's a surge chamber that comes off the manifold. Manifold's the right-hand side of the powerhouse, and the surge chamber that comes back up to that spiral access way. That was the critical parameter that governed the maximum output of the station when the tunnel was underperforming. The manifold begins the run right through to Deep Cove, and that's about 10 kilometres. 7 machines, 7 penstocks, and you know, all the machinery is down in the powerhouse itself. That was a picture I took when I went there in 1967. It shows you the face being excavated for all of those intake screens and preparing to drive the vertical penstocks. And just to the right, you can see a building, and it's got smoke coming out of it. That was the diesel generation for the power supply on the site. They had to have something like 20 megawatts of power. And to the left of that building, you can see a tower. I believe that tower structure, the lattice structure, sits over the first vertical shaft that went down to where the powerhouse itself was commenced. Large truck receiving rock that's been blasted out of the excavation face of the powerhouse. Those trucks had to drive up the spiral access way. They went up on the right-hand side of the access way, so the driver was able to be close to the wall of the access and pass another truck coming the other way. So the access was the first excavation to get down to the powerhouse. Bunch of men having a cup of tea by the look of it. So this is the tunnel. As I indicated, the tunnel was lined with a thin concrete lining. It was simply because it was constructed by drill and blast, the residue from drill and blast was too rough to leave exposed to the water. The losses would be too high. So a thin concrete lining was cast over that rough rock finish, simply to make it hydraulically smooth. This was the problem that was ultimately led to the second tunnel. The slip form that goes right around was hydraulically vibrated as the concrete was poured. It brought the cement to the surface, as you do when you're floating off a concrete slab. And that high cement-rich surface is what got eroded by the acidic water of the lake Manapouri. And the lake is acidic because it passes through a lot of rotted vegetation matter. And when we measured that tunnel surface, the aggregate exposure was converted to a roughness. We took that roughness to a Brazilian hydraulics expert, and he confirmed calculations that I'd done myself, that increased roughness was enough to raise the drag from what should have been 30 feet of operating head up to 100 feet of operating head. So that beast in front of you there was the fundamental reason for a second tunnel. Rotor being lowered down into the machine. When the machine hall was constructed, the very first erection was actually the crane. They set up the crane so that the crane could handle the lifting in of the machinery for excavation, the lifting out of excavation materials and so on, and also then the erection of the generators themselves. So the very first piece of machinery in the machine hall was actually the crane. Save Manapouri campaign. Look, I was at NZED when this was taking place. In actual, my own personal view was that it was a great thing. If we'd raised the lake, and originally I think the idea was to raise the lake some 100 feet, that was revised to something like 34 feet. But if you looked around the valley around Manapouri and Te Anau and imagined that lake 100 feet higher than it was, it would have been the ultimate in environmental desecration. I think in the end, not getting the 34-foot raise was also a massive environmental win for the place. And I wrote a paper in, might have been 2004 with Professor Alan Mark about the way in which that lake was managed to protect the lake shores around the lake, because they were incredibly sensitive to lake rise and fall. So in my view, the environmental compromise that came with the Save Manapouri campaign was wholly justified. Just a picture of the machine hall. I think it looks a little different now, actually. I think they're solid state exciters rather than rotating exciters. Those rotating exciters had carbon brushes, and the carbon brushes wore away and deposited carbon all through the machine hall. Of course, carbon tracks electrical high voltage, so not a great thing down there. Breakthrough of the second tunnel. Here we go.
Keith, you mentioned on the one slide there to Save Manapouri campaign. So just, and now it's more than 50 years ago. How do you think that changed the way we as engineers think about our roles and responsibilities as professionals?
I think it was a real milestone or a litmus moment. I mean, I've been around since 1950, and I've always had a deep interest in hydro. And in the early 50s, hydro was seen as the cheapest source of electricity for the country. And the rate of growth in electricity was north of 8% per annum. And the country simply could not build projects fast enough. And in a way, the Ministry of Works in those 50s and 60s era had enormous power. There was very little debate about the environmental consequence of what the ministry did. The legislation governing permissions was quite fragmented. A lot of it was administered by the Ministry of Works itself. So there was sort of a halcyon period of build as hard and as fast as you possibly could. And there were hydro campaigns in both the North Island and the South Island to do that. Manapouri was the first occasion when the environmental damages of that build as fast as you could program came to light. And it was followed up by a great deal of concern about the Tongariro scheme and the harvesting of water right around the edge of Ruapehu. And it ultimately came to pass as a deep resistance to the Clyde project. The Clyde project went through the normal permitting processes. The public resistance was so strong, those processes did not result in permission. And ultimately, Muldoon decided to write special legislation to force the approval of Clyde against the public concern. Really interesting today. If you were to go down to Clyde and say, gosh, we're going to dismantle this dam because of the environmental consequence, I think the uproar would be as great, if not greater, than the uproar that occurred when it was built. And I was sitting beside the mayor of Cromwell at the opening of Clyde. So I had the privilege of operating ECNZ at the opening of Clyde. And he quietly whispered to me, You know, those apricot orchards along the edge of the river, they were the wrong sort of apricots for the market. We were going to have to pull them out anyway. So there was a pretty big message for an engineer that you really have to understand public opinion. You have to be incredibly sensitive to the environment. We've only got one lot of environment, and we're short-term stewards of that environment. Even if you live for 80 years, you're a short-term steward. So social license is a critical determinant of what we as engineers should do and can do. And certainly with my hat on as chair of Transpower, that is a massive piece of the work we do in Transpower to ensure social license is retained to do what the public, of course, demand. They want electricity. We're going to use more of it. Our economy is going to be dependent on a greater proportion of electricity over time. So don't expect these questions to be easy to solve.
Yeah. So just to close off on that, Keith, or maybe Brett, so what's the current rating of the upgraded generation units?
Sorry, say again?
Yeah, there was a question about what's the current rating of the now updated generation units.
Brent should ask you that.
Yeah, I can jump on that one, Alan. So we, Keith described earlier the uprating from 105 to 121.5, which occurred during the half-life refurb in the early 2000s there. And then recently we've been working with Transpower and have triggered a small uprating to 128 megawatts per unit, and are in the process of looking to make another small incremental increase up to 131.5. So we're just in discussions with Transpower on that topic at the moment. But I guess, yeah, that those are signs of some of that sort of growth focus and rethinking the way that we operate plant at the moment, just to try and support the country's demand increases. So we're carrying across our hydro sites at the moment. We're trying to look for ways to operate them smarter and get out of that mindset of a base-loaded operating model. That does increase the wear on the units, and that's been quite a interesting discussion for us to navigate with our engineering teams around how we make our decisions in terms of managing the life of the assets and reinvesting in our assets.
Just a question Rachel had is this: so can anyone visit Manapouri?
So public visits ended, I think it was 2015, 2016. We had a visit from WorkSafe who took a look at the bus tours that we were running through the site using a third-party operator, and basically raised some concerns around the risk of managing a bus fire in the tunnel full of, bus full of tourists. So we put an end to the daily site tours that were a big part of our world until that point. We've made a number of investments in the safety controls within the tunnel, and for things like the 50th celebration, we do still run the odd targeted site visit using our own vehicles and our own staff to manage the controls. But the day-to-day site visits that used to occur have been parked. I mean, we would love to get a stream of students back through the site. We work closely with the Deep Cove Outdoor Education Trust, and it's almost been known as a rite of passage for Southland students to visit that site. We know that we're missing an opportunity to create an interest within the future workforce. So it's something we continuously chip away at, but we haven't yet established a robust system for running regular tours for the students that use that facility. We're working on it though.
Rachel has a follow-up question is saying her dad said it was something about a carbon dioxide safety system there.
We don't have, not like in the mining sector. I'm assuming that's where that question's targeted. That ventilation upgrade I talked to before, I guess part of the initial sort of consultation we did with the local council was how do we treat the facility, and can we classify it as a building, which we do. So we have designed that ventilation system to manage a certain volume of air changes per hour in accordance with any other industrial site that would run across the country. So we don't specifically monitor for CO2 buildup in the facility downstairs underground, but yeah, we do have a number of we have invested in a number of changes in that ventilation system based on the learnings from Pike River and the need to be able to segregate your different fire zones and maintain your whole response from above ground.
Yep. Thanks, Brett. So Caroline, over to you for a question, and because you talked about the major seismic upgrades at that one power station. And the question is just whether you can elaborate on that, if possible, on the level of percentage NBS the building was upgraded to, and what is the selected importance level? And what was
Yeah, sure. It was a wee while ago, but it's an importance level 4 building. And when we looked at Waitaki, it was actually an incredibly strong building itself. Our biggest problem was it was effectively 2 rectangles that were joined with no connection between the 2 ends of the building. So as the 2 ends of the building started to rock in an earthquake, the roof would fall in. So after quite a few years of different modelings and different looking at different solutions, what we ended up doing was a really, really simple solution developed by Naylor Love and WSP, which we basically just put a sliding joint on the trusses at the roof where they connected with the downstream wall, so that the downstream wall could wobble and the roof would stay in place. So we put about 100 mils of movement in that, which would allow the downstream wall to move up to 100 mils and the roof to stay intact. So the big concern was life safety, and while the roof would be damaged, would need to be fixed, it was just roofing. So it was a great solution at the end, and a really simple one.
Thanks, Caroline. And in keeping with you, yeah, so maybe just speaking, because we have this transition to renewable energy now. There's been 2 questions here. But first, Caroline, just starting with, how did you make the jump from transportation back into energy? And yeah, it's about the skills to do that jump, and how do we uplift the skills? And yeah, well, to start with your own personal journey, but it's also just thinking about for the sector as a whole, that we are going to need more engineers into the renewable energy space. So we need to think about upskilling.
Yeah, absolutely. My jump was an interesting one because my passion was in hydro. That's where I wanted to work. So when this opportunity came up and I saw this ad, I was like, wow, I can do all of those things that they were asking for. They were asking for a civil engineer who knew how to manage resource consents, knew how to manage contracts, knew how to do some public consultation. And they were all skills that I'd actually gained through doing roading upgrades and so on that I was doing. Although when I wrote my cover letter, I said, I have no experience in this field whatsoever, but I can bring you this relevant experience and my passion. And I was stoked when I got the job. Didn't think I would. I was on maternity leave, and I wasn't planning on going back to work that soon, but it was a great career move. I've been here 12.5 years now and haven't looked back. So there are a lot of transferable skills within the industry. I mean, I can only really talk from a civil perspective because I know my electrical colleagues, it is a bit more specialised and I don't understand most of what they do. But we're not just Meridian. A lot of generators have a really ambitious build program. And along with the build program goes transmission upgrades to support them. So it is, as an industry, we will be looking at additional resources. And I'm just not 100% sure how we do go about upskilling people, except for just getting some experience in the field. But from a civil perspective, roading or water type infrastructure projects is very similar to what we do.
Yeah. Brent, you want to say something about this upskilling? I mean, there was a question around, I mean, all the positions are always asking for experience, and that's always a sticky point. So, and I know some of the engineering companies do have sort of internships and so on available, but I don't know whether that speaks to anybody with a little more advanced in their careers.
Yeah, look, I think one thing that our people team have made some sort of deliberate changes in over recent years is the way that we advertise, and trying to shift the focus away from the technical experience that people bring into the workforce. We've learnt through our own experiences, and I guess it's pretty well known through the world now, that by bringing extra sort of minds, high levels of diversity to the team, that we can solve some of the really complex challenges that our industry is facing at the moment. And so I know in the Meridian world, our recruitment process places far less emphasis on your technical experience in the recruitment campaigns that we run today compared to where they maybe were 5 or 10 years ago. And we look a lot more to the attitude and personality that you bring to the role. So I don't know if that helps at all, but yeah, I know certainly within the Meridian sphere, that's a big part of our recruitment strategy at the moment.
Yeah, and I think it'd be a big issue for us in the energy sector in general is to get young people excited to enter into careers here. It's always a challenge, right? And maybe that speaks to one of the questions that came in, because we don't have these site visits there to excite young people, but maybe we do some virtual tour or we'll get that together. And it's certainly something I've spoken to my colleagues here that look at all these virtual reality kits and so on, and get young people to actually put on a headset and walk through a hydropower station, or through a wind farm, or through a solar farm, because it's not everybody that has the opportunity to actually get out and engage with that infrastructure and those assets. I'm going to say, I think we get a good place to end off as well, is just to get your each views. I mean, we're going into the future here. We have this aspirational target of getting to 100% renewables, and it's about decarbonizing the rest of the economy. What do you see as some of the major challenges with that? And perhaps thinking about what the vital role of hydropower is going to be, because we're talking about Manapouri here today, but just for the infrastructure in general, what do you think our main challenges are going to be, and how do we address those as engineers? Brett, do you want to start off?
Yeah, I'll try and keep this brief, Alan. That's a big question. Main challenges, I suppose, I guess when it comes to new development, that's it's not really my sphere. So Caroline might be able to give you a bit of an answer, but I know what does cause us a number of challenges at the moment is just the time it takes to get through the consenting process, to go from a plan on paper to turning that first sod. There's a lot of work that goes into that space. And with the rate of change of technology, I understand that it's one of the challenges our team face at the moment, that by the time certain designs are consented, some of the technologies moved that far on that we have to apply for a change of conditions. So I think that's certainly one of the challenges that's faced across the industry. And I guess linking to what, in the hydro space, linking to what Keith said before, just maintaining that social license to operate. That's certainly something we're acutely aware of in the world of Meridian. These hydro schemes, they've been a big part of our communities for many years now, but we are still very alert to the impact that they have in the regions that we operate in, and we pride ourselves in the relationships that we maintain with key stakeholders in those areas.
Great, thanks, Brent. Caroline, your thoughts? There was a specific question on how would you secure the future for New Zealand? Also a massive question.
That's too big a question for me. As Brett said, consenting is a process that we've got to go through. Another concern is just around grid connections. There's a lot of developers out there looking at new sites at the moment, putting a lot of pressure on Transpower with new grid connections. And the other issue we've got is supply chains. We are a tiny little fish in the bottom of the Pacific. We are playing with some massive international players who are also trying to do exactly the same thing as what we are doing. So we have to work hard to secure our suppliers. We need to understand the timeframes that we need to get things. For example, transformers have a really long lead time at the moment. So we're having to make some gutsy calls about procuring equipment early in a process in order to actually meet those timeframes. So yes, supply chain.
Yeah. Keith, the last 30 seconds, thoughts from your side. I mean, we have the renewable energy resources, we have the hydropower there, but might not be enough storage for us going forward with the variability, right?
Look, I think hydro is critically important to the future, because as we build new capacity, it's all intermittent. And the one thing that hydro gives us is controllability. We are just so much better off than Australia. I look, Caroline's point about supply chain and capability and resources, we are tiny fish. We only have a small job to do. Whether we get to 100% or not doesn't matter. What we will do is build our new demand will be supplied by new renewables. But I chair New South Wales Energy Company, and we have 50,000 megawatts of wind and solar to do, and $30 or $40 billion worth of transmission. The scale of that task is going to, if we're not careful in New Zealand, we will suck this country dry. And that is certainly the biggest challenge we have at Transpower, is maintaining our resources, particularly as we come into midlife refurbishment of transmission.
Yeah. Great. I think that's a good way to end this webinar. I'm going to thank the three panelists, Keith, Brett, and Caroline, for making yourself available and sharing your perspectives with us today.